two good questions that we kind of go for. So generating user data, storing it, and more importantly, specifically with this lecture in land of APIs, is how do we go about asking for data? Fortunately for us, this kind of stuff is pretty well standardized, you would think, after 40 plus years of the internet and things like that. These things are, for better or worse, standardized. So one thing, so a scenario you encounter every single day. I'm sitting over here on Chrome. Your friend might be sitting over there on Firefox. Somebody else, God bless their souls, might be sitting on Safari. Nobody on the planet Earth should ever be using Internet Explorer these days. But the point is that there's a whole bunch of different clients, a whole bunch of different users with all kinds of different operating systems, all kinds of different browsers, all kinds of lovely mess we see today, even the complexity of having all of these different things. Some of you had issues with Mac OS doing different things that Windows did. Some of you had interesting things with Windows 11. It's kind of a nightmare. But to prevent these errors that occur with OS-specific things, we have standardized methods of communication with other computers. So no matter what my specific client is, be it Chrome, Firefox, Internet Explorer, they all communicate in about the same way. And those communications take the form of requests and responses. My client will send a request to a server, and that server will hopefully reply with a response to us. And the specific, the clients send requests to servers, and servers send responses to clients. But the specific format of these requests and responses, you've known probably most of your life, whether you realize it or not. It's not exactly an email, but it's actually in the top of your browser bar at all times. The specific way most of us do these requests and responses is through HTTP or HTTPS. And as I think a good majority of you know, stands for Hypertext Transfer Protocol. And as you can see, it's very similarly linked with HTML, Hypertext Markup Language. This is because when they were standardized, they were made about the same time. And so you've been using these HTTP requests this whole time, so it shouldn't be just too much of a surprise. I think. All right. Well, I don't know what to do in that case. But so the specific layout of these requests and responses takes a form very similar to this. So your request has to have a location it's going to, which of course takes the form of the request URL. And your request will generally ask for some specific operation to be called. This takes the place in the form of the HTTP method. Additionally, there are specific headers that go along with a request and response. These can include more complicated things like authentication for specific requests. They include metadata about your specific client. So you'll have headers saying that, hey, I'm requesting from Chrome, I'm requesting from Firefox, my screen size is about this or whatever, because that might change the way the server responds. And generally, you might also provide a chunk of data with your request that takes, if I wanted to create a new comment or post in Catbook, I need to tell the actual data of that request or comment, which will of course go in our request body. And one extra little bit that takes place in this HTTP request style that will probably be particularly useful later. We'll talk about requery, and so this query exists as a part of the request URL. It's the lovely question mark name equals some value. There can be multiple variables in a query, but it just provides extra information to the server. In this particular case, when we make this API request, it will tell the server to grab all the comments with this specific parent. And so I talked about these. I talked that HTTP requests will have specific operations. So there are quite a few of them, but you probably won't encounter but maybe 3 or 4 of them throughout WebLab at the very least. And so they're fairly self-explanatory in name. Get is what will occur every time you open a page in your browser. Your browser will implicitly make a GET request to a site to get files. Post will be what is more or less used in the case of creating data. So to add a comment or add a post in CapLiquidator, we will make post requests. Put may or may not be used, but put can modify existing data to, if you like to actually follow HTTP recommendations and type things, you can use put to modify existing comments, and delete, well, deletes data. The rest of them you can read about in our good old lovely friend MDN. And as I alluded to earlier, you can use the line to specify where it has to go, body for other info, and headers for more fancy things that you probably won't have to deal with. But HTTP requests are, of course, only half of the story. So on the other end, we have server responses. So the server responses take the format of 100, 200, 300, 400, 500. And so you've also, throughout most of your life, probably seen quite a few of them. As I accidentally skipped to the other slide just a second ago, nobody saw that, nobody didn't. There was 404. So 404 is the server response code for it couldn't find what you were looking for. There's 200, which is technically, I guess, the most common code, but you probably might not have actually known it because obviously we don't need to say if something worked. It probably worked and you got what you were looking for, and so the server didn't have to tell you it worked. 500 is in the case of internal server error. If I do my job as tech share correctly, hopefully you won't see too many of those on any WebLab site. No promises. 400 is in the case of bad requests. But I could literally list random codes all day, but you guys want lunch. So the general theme for the status codes is that 100 codes are informational. You'll probably never see them. 200 codes you want to see, but you may not see as many of them as you wish. 300 codes are redirect codes. 400 codes generally means that you did something wrong, you as the client. And 500 codes generally means that the server did something wrong. And so throughout WebLab, you'll probably see the 200, 400, and 500 codes most often. I doubt many of you will encounter a 100 or 300 code. And so to slightly make this a little more interactive and not me just ranting for days on end here at the front of the classroom, One thing we can do to kind of see some of the requests, you can open up any page, maybe try Catbook just because that's the example that I'm going to have. And using either Control-Shift-I for Windows users, Command-Shift-I, or whatever cursor shortcut you put in its place, you can look at, so let's try in the case of this actual presentation here. So I'm going to do Control-Shift-I. Things are going to get tiny, but let's blow this up a little bit. One thing you can do is you'll notice that there's a network tab. And so if I refresh over here, and I make things maybe a little better to read, I can drag this up, and there were a whole ton of requests that occurred when I refreshed the page, because Google does a whole lot of things in the background that you never realize. And so as we can see, the vast majority of them actually were successful in 200 code, but of course I have some ad blocking things, so it blocked a decent chunk of them. But this is a great way to see, even when you're developing on your own a bit later, how some of the requests that your site makes, it's a useful tool along with the React developer tools and the Chrome or Firefox JavaScript consoles. And so, yeah, you'll see actually in the case of Catbook, apparently we do use a 300 code, or at least we did a year and a half ago. I totally updated these slides. So in keeping with some interactivity, we can actually make a couple of requests. So I've thrown a couple links into RecBin, which will it open? Yes, it will. So here, I've set up a request to weblab.mit.edu/geek. And unfortunately, I haven't made a geek section of weblab.mit.edu yet. So naturally, the server came back after a lovely 70 milliseconds with a 404. And by default, it renders this lovely little page. If we like requests that don't quite fail, one thing we can do, I found some random ASCII art. I have no idea what it says, but here this will give us an actual okay response. And so this is what we like to see in our lovely coding land. Before I jump more into API stuff, anybody have any burning questions at the bottom of their soul? All right, cool. So now to actually define what an API is. So APIs are application program interfaces. They are a set of endpoints. I'll define what an endpoint is in a second, that services allow you to make requests to. So companies like Google, Amazon, and Facebook, they all provide APIs to implement their services with. And these APIs, their reason for existence is that you like data, you need data to work with to make your components actually work with. You need users' data, you need their like information, their posts, and everything. But for a site as large as Facebook, they're obviously, for both security reasons and for your mental sanity, not going to let you directly access data off of their servers. So in Facebook's case, if you personally want to work with some of Facebook's data and they're feeling lovely enough to share it with you, they'll create an API that forms a structured way for you to ask for this data. And so the places you make these requests to, these specific URLs you send requests to, are the endpoints. And so you can do a whole bunch of lovely things just by asking the right people very nicely. And so, yeah, this API is the layer in between all of our clients and data you might need to serve them. So some specific cat book related endpoints that we'll have later. Um, we'll have some stories endpoints that we can send GET requests to. We can have a story endpoint with post requests. Now, we didn't technically have to make those two separate endpoints. We could have, as we did in the comment case, we had one singular URL, in this case, /API/comment, that the server will do different things based on the HTTP method of the request that you send it. And so in the case of comment, it will either get a comment or make a comment based on whether you send it a get or post request. But so take this restaurant here, for example. Here it has an embedded Google Maps within it. And obviously this restaurant isn't Google. And obviously this restaurant hasn't hacked into Google's lovely servers and databases. So whoever made this website for the restaurant figured out how to utilize the Google Maps API. And a lot of you, probably most of you, will end up using at least one API in making the functionality of your site because it enables a lot of really cool functionality that you don't have to code from scratch. You're more than welcome to make Google Maps from the ground up in 4 weeks. I will certainly give you an award for that. So there are a bunch of cool APIs. So there's the Google Maps API, there's the dog API. So the dog API here will, every time you send a request to it, give you a link to a doggo picture. So here we have a doggo in a red jacket. Next, you might have heard of OpenAI. They do things like GPT-3 and a whole lot of more complicated things. You might potentially use their APIs for things. That way you don't have to train your own lovely models. You can just use their models and send requests and they will hopefully give you responses. The final thing I just want to meet as a development tool for API stuff later, there's a tool called Swagger that makes visualizing APIs a little easier. So here's a lovely demo they've made, the Swagger Pet Store. And it provides a nice, lovely way to group and visualize all of your API requests and endpoints in one location. So we can see that here is all of the requests pertaining to pets. We can upload images, we can make new pets, we can modify pets, and it shows color-coded the different methods for each of those. And each API endpoint might ask for different information. So here we need to upload for a specific pet ID, and it reminds us what information we need to pass along in that, and we can give it mock requests, and it will give us mock responses. But in general, I think that's pretty much the short gist of how servers and APIs work. And are there any announcements we want to do before lunch?